Today we're going to talk about a form of energy that should be relevant to all of us. It's what gives us the energy to do everyday tasks like move, like play basketball, like do math, do science. And that is chemical potential energy. That's the energy that we get from food. And I would like to look at a situation that we probably have all experienced, and that's fast food. I'm personally a fan of fast food. However, in our nation, there's a problem with obesity due to a lot of these fast food chains, and I'm going to look at exactly why that is today. So let's look at this Big Mac meal. This Big Mac meal, let's say that I got a Big Mac meal, but I got it with a Diet Coke. So I'm just going to throw out this Coke right here. This is giving us 0 units of energy. And before I get into this, I just want to talk about what energy units we're going to be using. So usually in science, when we talk about energy, we use joules. However, in our society, we've chosen to use a different unit of energy, and that is calories. So that is calories, and I'm sure you've seen it on the back of the nutritional facts that they list the energy in calories. And the reason why they use calories is just easier to use with how much energy food has. And one way to kind of think about it, what I'm talking about, this relationship between joules and calories, it's like the same thing as just saying, okay, feet, I need 2 E's, and meters. So feet and meters, they both tell you the same thing. They both give you a length or a distance. However, they have different units. So the feet, what makes up a foot is 12 inches, a meter is 100 centimeters. They're different sizes, but they tell you the same thing. Joules and calories work the same way. They are both units of energy. However, they are different amounts of energy. They're different units. So now that you understand that, we're just going to use calories because that's what society uses in order to calculate the amount of energy that food is giving you. So a typical Big Mac has 550 calories of chemical potential energy that it'll give you. And French fries has 500, and this is a large fry, by the way, and these are all real numbers. This is I went to McDonald's website and I got their nutritional facts and I looked for how many calories each of these things are. So this is not an exaggeration. This is the total amount of calories that this meal, if you were to go today and order, this is how many calories you would intake. So to get all together, 500 plus 550 plus 0 calories from the Diet Coke, that's going to equal 1,050 calories. So if I eat this meal, it's going to give me 1,050 units of energy here. And now the question I have is, which I'm going to be looking to answer, and a question like this will be on the test, I guarantee you, so if you're watching this, that's great. The question that I will ask is, how many hours of walking will it take to burn off the energy from this meal? Alright, so now let me break down what this question says real quick. Let me get rid of this because it's kind of getting a little claustrophobic here. Alright, so how many hours of walking will it take to burn off the energy from this meal? So if you look at it, there's 1,500 calories. So I'm asking how many hours of walking. So that will be the variable that I'm looking for, is how many hours. Right? It's asking me for how many hours. So that's what I'm going to solve for. Will it take off to burn the energy from this meal? And now I want you to be careful because we've learned that we cannot neither create or destroy this energy. So when I say burn off, and the reason I use burn off is because that's typically what we use as a society. We say how many hours of working out does it take to burn off the energy that I ingested? And burn off, what I mean by that, and what our society really means by that, is how many hours of exercise will it take to transform this energy right here into a different kind of energy, one that will not cause me to gain weight. And if you think about that, when we work out, there's friction between us and whatever object we are moving, and that causes thermal energy. There's also thermal energy from us getting hot. When we sweat, we give off thermal energy. Also, there's the sound, so whenever we are running, there's a certain amount of energy released in each of our steps when it hits the treadmill or hits the ground. There's a certain amount of energy released. So when I say burn off, it's not saying that this energy right here is being destroyed. It's being transformed into a different kind of energy that will not make us gain weight. In order to figure out the answer to this question, we're going to need to know an important piece of information, and that's how many calories we burn from walking in an hour. And so I just went online and I Googled this, how many calories do you burn in an hour of walking? And I found that a pretty typical answer for the average person is about 200 calories per hour. And now a lot of people probably see this and say, okay, and this is easy, you just divide 1,050 calories by 200 calories and that'll tell me how many hours. And I just want to show just the mathematical reason for why that is true. So in order to solve this problem, you can set these two things equal to each other because I want to see how many hours it takes to burn this amount of calories. So 1,050 calories. And then we're going to write that over 1. And it's the same thing. Adding the over 1 doesn't change it at all. Anything over 1 is just itself. But I'm going to do that because, as you've probably done in middle school, we're going to cross multiply in order to solve this. So real quick, let me make some room. Alright, that's a little bit better. Now you guys can see. So in order to cross multiply, you're just going to take what's on top on the left side and you're going to just multiply it across like that. So 200 calories times 1 is just going to give us 200 calories down here. 200 calories. And then 1,500 calories, and we're just going to cross multiply that with the hours, and that is a variable. Remember, it's a letter, so anytime we have a letter without a number in front of it, that's going to be our variable, and that's what we're solving for. So we have 1,500 calories times this variable, which is hours, and that's what we're solving for right there. So in order to solve this, you're just going to now do the 1,500 divided by 200. And that's going to equal 5.25. And then the calories cancels out with the calories because they're the same thing. If you have something over another thing, those things are just going to cancel out. So calories cancels out with calories. And then you're left with hours. So it's going to take what this is saying, and I'll get rid of all this math over here. What this is saying is it's going to take us 5.25 hours of walking in order to burn or transfer this energy, this chemical potential energy, into different kinds of energy that will not make us gain weight. So it's going to if next time you go to McDonald's and you get a Big Mac meal with a Diet Coke, just understand what you're doing to your body, because you are saying that this meal that I am going to eat now is going to take 5.25 hours of walking in order to burn off, which is a pretty incredible thing. So this is an example of an energy transfer. I'm transferring energy from chemical potential energy, which is this 1,050 calories, into a different form of energy. And remember that energy cannot be created or destroyed, so the amount of energy that I release when I do exercise has to be the same. So you're not actually creating or destroying energy, you're just transferring that energy to a different form that will not make you gain weight. Thank you for watching, and I hope this helped. If you have any questions, feel free to ask.